Good afternoon, good evening, and good morning, everyone from around the world. It's with great honor to co-moderate this Datathon panel with my colleague, SPE colleague, Pushpesh Sharma. And this panel is a special occasion for me as this is my third Datathon and the third PIVOT conference since 2021. I'm Silviu Livescu. I'm the Society of Petroleum Engineers Technical Director for Data Science and Engineering Analytics. And I'm here to present the Datathon that the Society of Petroleum Engineers with the Department of Energy with Project Inner Space organized since March. And so the goal of this Datathon series is to bring the global SPE membership together and increase awareness about geothermal energy, and also bring forth the similarities between geothermal and oil and gas technical expertise. This was the second Datathon in this series, the third, as I mentioned earlier, on geothermal, organized in North America. And so the Datathon was a collaboration between a lot of entities. I mentioned Society of Petroleum Engineers, Data Science and Engineering Analytics Technical Section, SPE Gulf Coast Section, the largest SPE section in the world, the US Department of Energy, Utah Forge, and of course, Project Inner Space. Thank you very much, Jamie. Thank you, Danny and Taylor, for all your help to organize this event. The SPE Geothermal Datathon this year challenged participants to solve a geothermal engineering problem using real field data from Utah Forge, from the Utah Forge project. And if you remember, or for those of you who've seen this data repository, they have more than 200 gigabytes of data available for everybody on their website. I'm teaching a geothermal class. I'm teaching a machine learning class at the University of Texas in Austin, and my students actually are using that data almost for each class for their projects. Great data. This year, we had more than 150 participants representing 21 countries and 18 teams, which is a big improvement comparing to last year when we organized the first Forge Datathon. We had 100 participants last year, so an increase year over year by 50%. Great stuff. So we also organized, all kinds of boot camps. We had videos online available for YouTube for everybody who is interested. Actually, just Google or send me an email, and I can point you of how much information is out there about the subject matter expertise going into these Datathons, about the videos of the contestants, and so on. At the end of the Datathon, the subject matter experts who organized the Datathon gathered the 4 finalists that we are going to meet today and carried out a session to give detailed feedback about each submission to close the circle and assure that the young professional had an idea and understanding of the strengths and weaknesses of the submissions, and so fulfill the mission of knowledge transfer. We are going to introduce now the 4 representatives of the best 4 teams, and so I would like to start first with Juan Ignacio Sívori from FDC de Argentina. The second one is Ning from Colorado School of Mines in the United States. The third one is Li, standing in for Sangkeon Park from Seoul National University. And the fourth one is Keivan Khaleghi from University of Texas at Austin. And so I didn't talk about the scope of the Datathon, about the assignment and about the requirements of it. I would like actually now for the next 20 minutes or so to go with the four contestants and hear from them the impressions about the Datathon, the experiences, the learnings, the takeaways, and so forth. And so I'd say let's start with the first question. Why did you join the contest first? And so I would like to go, among all of you and have 1 minute each about your experiences. So let's start on the order of my screen with Daisy.
Hello everyone, my name is Daisy Ning. I'm a research associate at Colorado School of Mines based in Denver, Colorado. So the reason why I joined this Datathon is that currently my research is more related to subsurface modeling. So I have experience with unconventional reservoir development and also carbon capture and sequestration, which is short as CCS. So I had been interested in a geothermal project, but never had a chance to work on it. So this Datathon gave me a chance to work on the geothermal project, and especially considering that the data is from a real project. So this gives me the opportunity to transfer my previous experience and also learnings, and that can be directly used in geothermal. So I think this is the main reason that I joined this, and I have to say it is a really good experience. We are the team of the thermal seekers. So there are 5 people in our team. So we have different backgrounds. Some are geophysics, some are engineers, and also some are students. Some are independent software engineers, and some are the retirement geophysics. So I just think that this is such an integrated team. We worked together to finish this project and also deliver the video. So I just think that it's a nice experience. I would encourage. So next year, if there is a chance, I would encourage all my colleagues and also students in our department to join it. Yeah, that's my experience. Yeah, thank you.
Excellent, Daisy. Thank you very much. I have to echo what you said. Your team was absolutely diverse and the true spirit of what we are trying to achieve here about collaboration and about bringing the geothermal and oil and gas expertise together. So thank you for that. Juan, can you go next?
Okay, yes. Well, hello, everyone. Thank you for being here. So the reason why we joined the SPE Datathon is because Juan Manuel, my teammate, and I, we are both petroleum engineers from Argentina, and we find that the geothermal industry is not very common in Argentina. So we decided to participate in the Datathon because we both are petroleum engineers. That is a profession that has some links with the geothermal industry, and also because we like this thing of programming, of coding, of creating algorithms to apply into the engineering field.
Excellent. Thank you very much, Juan, and thank you for joining. I know it's a different time in Argentina. Great stuff. Keivan, you are the next on my screen.
Thank you, Silvio. No, this was a great and educational experience for all of us. My team NDT, I want to give a shout out to the other members of the team, Pallavi, Tri, and Femi. We're all students at the Department of Petroleum Engineering at the University of Texas at Austin. And we had varying degrees of exposure to geothermal data sets. But I think we really came together. It was a great exercise in team building and also kind of a fast-track learning experience of this particular unique data set that will be very useful for our research as well.
Excellent. Thank you, Keivan. And Jinkyo?
Yeah. Hello everyone. I am Jingyo from Seoul National University in South Korea. And actually, our team had an opportunity to visit the geysers in California in January. And at that time, we got some information regarding this datathon, and we thought it will be really a fascinating opportunity to deal with real data and really understand what's going on. So our team consists of 2 graduate students and 3 undergraduate students. So all of us we had a really challenging time, but it was really a good opportunity to join this datathon and get to know more about real data analysis.
That's great. So Jinkyo, thank you very much, especially to you. It's 5 o'clock in South Korea, so this is not an easy, panel for you, but thank you for joining us. And so this is all great. I'm actually very happy to hear your perspectives. Now, a little bit more challenging question. How much did you know about geothermal before you actually started this datathon? And let's try the other order. So Jinkyo, you want to go first?
Okay. In our university, we have a class named Geothermal Engineering Energy Engineering. And actually, I took the class when I was the undergraduate student. And then my last experience regarding the geothermal energy is the visit to the geysers. So I think I had pretty much learning experience, but I never had an opportunity to really do some research regarding it. So I just know what they have in the textbook, but it was my first time to be included in research.
Excellent. Great stuff. Keivan, you can talk about the great geothermal class you took at UT before this.
Sure, you stole that line from me. Yeah, so I like similar to Jinkyu, I also took a geothermal class with Dr. Silviu Livescu in person here, and it was very informative and educational. But again, similar to what Jinkyu said, I think it's really I would say interesting that you actually deal with real world data. And a very specific type of data. In this case, it was microseismic data, which personally and other members of the team, we didn't have exposure to this data before. So for us, it was a rather steep learning curve in the beginning, but the boot camps really helped. And then actually reading a couple of SPE papers helped. And we had a couple of YouTube videos from the professors in the department here at UT Austin that also were quite helpful. So it was a great way to learn about this particular data set.
Excellent. Thank you, Keivan. Juan?
Yes, well, with my teammate, we didn't have any topic related with geothermal in the university, but Juanma is studying at IFP France, so he has been in contact with the topic. Another thing that I wanted to say is the microseismic was also a topic that we were not familiar with, so we struggled with it at the start of the competition. But then we think we understand it.
Excellent, Juan. Thank you very much for that. And Daisy?
Yeah, I have to say that this is the first geothermal project that I have worked on. However, my colleagues at school months, they have been involved with the Forge project. But for our team, so we have the geophysics, we have petroleum engineers, and we have software engineers. So they have lots of experience related to oil and gas industry, all related to subsurface data collection, modeling creation, but though it's not related to geothermal, so all the skills can be directly transferable. So I think based on this project, I probably can use this to as a start point to write geothermal related proposals and work on more geothermal projects starting from now. Thank you.
All right, thank you, Daisy, for that. Now, regarding your preview answer, Daisy, the first one, let's start with you again now, and I would like to hear your perspective and everybody's perspective on actually how your working teams, how you coordinate it, how it happened, how you actually make it work to the final presentations.
Yeah, that's the So in the start, based on the timeline, we just we had a sort of a meeting so that we separated the whole team into two groups based on the tasks. So one is mainly focused on the microseismic, and the other is mainly focused on the production well placement. So we have meetings every week and to discuss the progress and to see if there are any interesting papers or findings that can be shareable with everyone. So one frustrating thing is that in the beginning of the Datathon, actually we were not provided with the GeoDT code. So initially we tried a different way to start with the second task. So in the middle of the Datathon, the code was provided, and then we think that it might be better to use the GeoDT instead of our previous method. So that one, yeah, we spent some time there, but yeah, finally, everything worked. And also at the end of the Datathon, especially the last week, which is because I think everyone is busy at that time. So we just had meetings every day, make sure that we can submit the final required document on time. So I think that's my experience. Thank you.
Excellent, and a great example of teamwork here. As I said, a very diverse team and a great outcome watching your video. Juan?
Okay, so we try to arrange one meeting per week, or maybe one meeting every 2 weeks, just on weekends, because well, as I said, Juan is in France and I'm here in Argentina, so sometimes it was difficult to combine the hours, and well, so we did that with we worked with meetings, and then we try to define some tasks for each of us to complete and until the next meeting. So that was the way we work for this competition.
Excellent. Thank you, Juan. Keivan?
Yeah, similar to what Daisy and Juan said, I think we had kind of a check-in meeting every week or every 2 weeks, and we delegated kind of the tasks, kind of focusing on clustering, focusing on kind of the literature review a little bit between the members of the team. And then once the solution was a little bit more clear, we also focused on the GeoDT side to the flow simulation. And, like I said, we're all students at the University of Texas at Austin, but we were also doing internships and research during summer. For example, I was at the Geysers, and I had another team member was in Houston, and two other members were in Austin, actually. So we had to kind of coordinate around that, spend a few sleepless nights, but it was fun.
Don't do that. just get good night sleep. Yeah, thank you, Keivan. Jinkyo?
Yeah, we also had weekly meetings for this with lunch and we always brought something that we've learned new or what we have figured out, and some professors from geomechanics and petroleum also joined, so we can briefly talk about what we have achieved after the former meeting. Actually, we spent a lot of time for the first part, regarding the fracture plane. So we were a bit in a hurry for the flow simulation. We also used GeoDT, and it was almost end of the semester, so I think it was kind of busy to like wrap up and prepare for the presentation.
Excellent.
However, everything went well.
Jinkyo, let's start with you.
So we interact with our mentors every week.
Wow.
And we also had spent some time with them to finalize our results. We always showed our new results to our professors so that we are in track. We wanted to check that everything is in track. Since they have more experience, we thought it was very we were very lucky to hear about them, regarding their experience and their knowledge. So I think we were very lucky.
Excellent. Happy to hear that. Keivan?
Yeah, I would say I agree with Jinkyo, and also I would say the boot camps were really amazing. Some of them covered more kind of a general aspect of geothermal industry as a whole, and some more kind of really focused on the problem that we were trying to solve. And also the feedback that we got from the referees was, I would say, incredible, because it really gave us the next step if we wanted to take this further. And I would say if we come across this kind of data in our careers, we're going to have a greater understanding due to that feedback from the referees. So really appreciate it.
Excellent. Thank you, Keivan. Juan?
Well, I found it very, very useful, because I was not into the geothermal industry, so it was very, very helpful for me. And well, then the wrap-up presentation and the feedback, I think it's very important for us to a feedback to know which are our strengths and also our weaknesses.
Excellent. Thank you, Juan. And Daisy, the last one.
Okay. Yeah. I also really like the boot camps, which provide us lots of information about this about the skills that can be directly used in this data song. And also, I want to mention that actually after this data song, our team members have contacted Lookbresh to see if there is an opportunity that we can together to improve the GeoDT open source software. I think that might be something that we can do in the future. Yeah, thank you.
Wow, excellent. Well, 20 minutes went really fast. I'm really enjoying the discussion with you, but unfortunately we have just a very limited time. And so talking about SMEs, now it's my pleasure to introduce my co-moderator here, Pushpesh. Pushpesh is a long-term SPE volunteer involved in pretty much everything that means data science in SPE, and now he is the SPE Data Science and Engineering Analytics technical section chair, among other hats. I want to acknowledge you, Pushpesh, and also Sushma Ban, the new data science Data Science and Engineering Analytics technical director, taking from me this honor after in October next month. Pushpesh, if you don't mind to say a few words about yourself.
Oh yeah, definitely. Thank you, Silviu. Thank you for the introduction, and thank you everybody for joining. And I'm happy to see the participants and hearing the feedback. Just as an introduction, I professionally work with Aspen Tech as a senior product manager. But as Silviu mentioned, I deeply get involved with SPE activity. I'm very passionate about all the things that we do in SPE. So it's good to hear this feedback. And like I'm looking forward to contribute more in data science and geothermal overall.
Excellent, Pushpesh. What's your perspective about the Datathon, given the fact that you actually are the chair of it?
No, I think the Datathon are that we've realized in the past 3-4 years that Datathons are the event that provides the maximum value. We get a lot of engagement from participants. The main thing is boot camps, as everybody kind of echoed that boot camps were very helpful, especially for if you're jumping from a conventional domain to a neo domain. Boot camps are the key, and we want to use them as a repository for future students because the boot camps we already recorded. So there is already a repository that we can reuse for multiple generations to come. So it's a very good kind of resource for everybody to have. And then as hands-on experience is the key, especially for machine learning, data science, and also combined with geothermal. So that's the one thing that we kind of strive towards, and we want to do more. And I think we'll look at the feedback from this Datathon and try to keep improving on this. But this is something that we'll continue doing in future.
Yes, and Pushpesh, excellent comments. One thing, if I may add, is we now have a great group of volunteers with the experience to organize Datathons. What we always need is more volunteers, young volunteers to come and help, and also more attendees. So there will be plenty of opportunities going on between Project Innerspace, SPE, and Geothermal Rising through GeoD, the new project, as you know. Plenty of opportunities for volunteers. So this is a call for volunteers, literally all 4 of you and everybody else who can who listens and he can join.
Yeah.
So thank you for that. Pushpesh, you want to introduce the video now?
No, yeah, I think let's play the video for the winners.
Hello and welcome to the SPE Geothermal Datathon presentation from the Thermal Seekers team, a diverse team of researchers and consultants put together to offer a unique solution for the UTF-16A Enhanced Geothermal project. Our basic approach and solution follows the outline shown from the problem statement and objectives. Would go through the microseismic plane interpretation and how we developed a unique DFN model. The optimum location of the production well is then identified after some sensitivity analysis, and finally, the approach of reaching the project stretched goals, as well as added improvements with the lessons learned during the projects addressed. The main challenge is to identify the best location to drill production well 16B. This would be realized from the microseismic data collected from a 3-stage stimulation done on the highly deviated injector well 16A in April 2022. The best location is identified such that the overall thermal recovery and the economics of the project is optimized for the given period under consideration. A basic description of this well 16A is shown. The blue line shows the 65-degree deviated well 16A. The green dots delineates the position of the sensors in adjacent wells 56, 58, and 78B 32. The pink dot represents the 3-stage stimulation location. Stage 1 was carried out in the 200 feet open hole section of the well at a maximum rate of 50 barrels per minute with maximum surface pressure reached at 4,000 psi. This was done with slick water between 10,560 and 10,580 feet. Stage 2 and 3 were stimulated after isolation of a 200 feet long interval of the 7-inch cased hole section. Maximum pressure reached for both cases were above 6,000 psi with maximum injection rate of 35 bars per minute. Slick water was used in stage 2, and cross-linked polymer was used in stage 3. Stage 3 also included micropropans to investigate well connectivity during the drilling of 16B, and stage 2 included a sudden shut-in as shown in this image. The red bars represent the trigger rates, the blue bars represent located events, and the gray bars indicate noise trigger rates. The events recorded all lie between magnitude of range -2.3 to 0.5, indicative of little or no risk of induced seismicity that may pose danger to the environment. We will now take you through the generation of the DFN model.
Fracture DFN was developed in several steps that leveraged open source software, in particular the scikit-learn dbscan method. This method uses two parameters, the minimum number of points per cluster and the distance to reach out to add points to the cluster. The latter may be considered equivalent to how many outliers are allowed by use of search methods. dbscan is first applied to a time variable, in this case the square root of elapsed time from the first event. The event data in each of the time groups was then analyzed for spatial clustering using dbscan. The data in each spatial cluster was analyzed using principal component analysis to generate a fracture. At the end of this step, we had 73 fractures and 25% outliers. Two methods were used to harvest the outliers. First, each outlier was evaluated to see if it was close to a fracture and could be captured by an existing fracture. This left about half of the outliers remaining. dbscan was then used a third time with relaxed parameters to see if any of the remaining outliers were suitable clusters for fractures. An additional 14 fractures are created, and the residual remainders were reduced to less than 4%. Of these 87 fractures, it was seen that some were very close to each other. With a relative error estimate of 2.5 meters, a distance of 10 meters of separation between fracture means was considered sufficient to distinguish two fractures. Fractures less than 10 meters apart were fused together, resulting in a reduction of 24 fractures. It was then realized that stages 1 and 3 had very good connections of map fractures in the borehole, but stage 2 had no fracture intersection at the perfs. To address what might have been aseismic flow, one horizontal and one vertical fracture were added to stage 2, resulting in 65 map fractures and only 105 events were not associated with a fracture out of the original 2,798 events. This chart illustrates the use of dbscan for clustering in time and space dimensions. At the top, data for each of the stages is provided that shows the different clusters in colored dots. A total of 54 time groups were established. Along the bottom of the chart, easting, northing, and northing by depth charts show 4 spatial clusters for one time group. Each of these clusters corresponds to a map fracture plane. The outlier harvesting process reduced the outliers from an initial rate of 25% to a final value of 4%. Along the top, the first step is shown in which the outliers are mapped into existing fractures. The red dots in the top left chart are outliers, and to the right these are converted to blue dots associated with a map fracture plane. The second step is illustrated along the bottom, showing 4 of the 14 new fracture planes that were developed using dbscan on the outlier population using relaxed parameters. The final residue of 105 outliers is less than 4% of the initial population of events. The fracture maps were then modified by fusing fractures, illustrated at the top where 3 fractures are shown that were combined into one. The separation distance between frac means was small relative to the error criteria. On the bottom left, the initial stage 2 map is shown. There was no fracture connection between the map fractures and the perforations, thus vertical and horizontal fractures were added to represent what must have been aseismic flow. Each event location was mapped onto its fracture plane, and the perimeter was established using the convex hull function. This function also calculates the area of the enclosure. The raw fractures shown at left were converted into circular fractures shown on the right by calculating the radius of the circular fracture to match that of the convex hull area. This chart shows the resulting SERIONET and ROSE diagrams of the fracture system. The polar plot shows the predominance of vertical fractures, but there were a significant number of inclined planes too, particularly for stage 2. In stage 3, we had mostly vertical fractures, and stage 1 had more of a mixture of vertical fracts and inclined planes. The ROSE diagram shows a dominant trend of north 20 degrees east in agreement with other data from the field.
Production well placement. So determining the ideal location for the production well is a crucial aspect of any project due to the numerous variables involved. A comprehensive understanding of subsurface activities is needed, which includes understanding the subsurface geology, thermal structure, rock type, porosity, permeability, as well as the existence and characteristics of faults and fractures. Since the main objective of this project was to pinpoint the production well's location, our focus as a team was primarily on testing parameters related to the well, which included injection rate, well spacing, well skew, well toe, well face, and well proportion. Some of these parameters are highlighted in the slide, and we executed various scenarios to fully comprehend the impact of each parameter. And another thing that I would like to add here is that we stuck with the default setting of the GODT model, which was an open hole.
When using the DFN model as input, we ran the simulation model using GODT. But before that, we updated the values of all model parameters to appropriate numbers based on the publications that are related with this fervo project, especially those related to the injector 16A. We also fixed the seed number to ensure that the scenarios of the different scenarios can be compared to each other. Here, we assume there is no natural fractures. So we realized this by commenting out the function called generate joint size. We used the running time of 20 years and also the boundary size of 1,200 meters. So as shown in this figure, the production well is represented by this red line, and the injector is represented by 3 intervals. When importing the DFN model, the fractures are only located in the first interval. So we replicated the DFN model for 2 more times to ensure that there are fractures in all 3 intervals. The figure below shows the flow path that connects the injector and the producer. Multiple scenarios were run with the goal of identifying the best location for the producer. To start with, we tried different well spacing and injection rate. As shown in this figure, y-axis represents the net present value, x-axis shows the spacing between the injector and the producer, which ranges from 50 meters to 500 meters. We also tested different injection rate, ranges from 0.04 to 0.02 cubic meter per second. So from here, we can see that when the well spacing is not greater than 200 meters, we can see there is consistent negative NPV. But when the well spacing is equal or greater than 300 meters, then we can observe positive NPV. So when the NPV is high, then we can read the well spacing, which is 400 meters, and the injection rate is 0.03 cubic meter per second. Then we use this scenario as the base scenario, and then change the parameters related to well geometry. So in the base scenario, we use the skew toe equals 0, and also the phase equals 270, and also the proportion equals 0.88. So here we just changed the value of these numbers, these parameters. And then we found that when the well skew is -5, and the phase is 240 degrees, and the proportion equals 1, then the NPV is higher than the base scenario. And then we put all these values together and then run another scenario, but we found that NPV is lower than the case when the proportion equals 1. Then we think that this is the best scenario, meaning that the length of the injection equals that of the production well. The figure here shows the production results from the best scenario. So we can see that the production enthalpy, the production temperature, and also the thermal extraction decreases over time very slowly. So in this best scenario, we found that the well spacing is 400 meters. The well length of the injector should be equal to the producer, and also the producer is parallel to the injector because both the well scale and the well toe equals 0. And also the producer is directly above the injector. Here we use injection rate of 0.03 cubic meter per second.
Flow and heat transfer through the fracture network was modeled using open source software Geothermal Design Tool, also known as GeoDT. GeoDT is convenient for this purpose since it requires only a DFN and optional rock properties as input, but it uses a high degree of randomization, which presents a challenge for conducting parametric studies of the results. The software could be improved by reducing the use of random numbers in its algorithms in order to generate reproducible results. It is also unclear how certain rock properties affect the results, and more concise documentation of these properties and their effects on the results would be helpful. Another potential improvement to GeoDT would be the development of a user interface. Although it is currently research-level software, a user-friendly front end could increase usability and appeal to a broader community of users. The DFN processing method that was developed here produced fracture maps that were stable and consistent with visual interpretation, without the need for user interpretation. As mentioned previously, GeoDT was useful for modeling heat extraction, and some preliminary trends were identified. Further research with additional parametric studies could result in more conclusive findings.
All right, Pushpesh, that was quite something, huh? What do you think?
Yeah, it was pretty interesting.
All right, so should we go with the winners?
Yes. So maybe I can start.
You start. Yeah.
So the Project Interspace Geothermal Data Champions, the first prize winner is Thermoseekers. So congratulations.
So Ning, yeah, from Colorado School of Mines is here to receive the award. The second place of the Project Interspace Geothermal Datathon is Team NDT, and Keivan from University of Texas at Austin is here to represent the Team NDT.
And third place is SNU Geothermal, and we have Jinkyo Lee from Seoul National University to receive this award, but congratulations.
And the fourth place is Geo Warriors with Juan Ignacio Sívori representing the team. Thank you very much. Congratulations. All of you really hard work and really enjoying seeing your results.
Yeah, just wanted to add same thing, Silviu, that even though we had to rank, that's the part of the competition, but I think you already heard from the judges during the wrap-up meeting. They were super impressed. Everybody was super impressed by the work that every team did. And as we have seen, it was a pretty involved competition. So nothing is taking away from you. It's like, I think you put a lot of effort, and I wanted to congratulate every team and then keep up the good work. Thank you so much.
Excellent, Pushpesh. Thank you very much. Thank you, Pushpesh. Thank you all contestants. So with this, actually, we made it to the end of week one in the Pivot conference. Let me thank everybody for staying until the end of the day. So we have a lot of exciting panels coming up. Remember that we will come back next Wednesday, September 13th. with great panels that will highlight the global efforts shaping next generation geothermal. We will travel to China, to India. We'll deep dive into the risk of industry seismicity, and we'll have our Jordan Nielsen R&D disruptive competition. Thank you all. Great week. See you next week.